Welcome back. Today we're going to talk a little bit more about exponent rules. So we have the power of a product rule and the quotient, the power of a quotient rule. So the first rule says that for all real numbers A and B, so A and B are allowed to be real numbers, and for all integer values of C, so C can be positive or negative whole numbers, okay? Or whole numbers and their opposites, which are integers. It says that when you have two things that you're multiplying here, you can take the exponent and put it into both of the factors, right? So what we're doing with the C here is that we're raising each of these factors to the power of C, okay? And this actually works if you have more than two factors. So let's say you have A times B times, I don't know, F times E, for instance, to the C power. You take each of the factors, A to the C power, B to the C power, F to the C power, and E to the C power. All this is saying is that if you have two things, you can either multiply them first and raise it to the power of C, or you can raise each of the factors individually to the power of C and then multiply them second. So it's like saying that the order of operations, it's the same whether you do the order of operations correctly here or whether you do it here. Okay. And so let me just give you a quick reason for this. Let's say that you had two numbers like 2 times 5 squared. Well, 2 times 5 is 10 squared. We know that's going to be 100. That's the same thing as saying, so our rule is saying that this is the same thing as saying 2 squared times 5 squared. But that's just 4 times 25, which is also equal to 100. Right? I didn't need to put parentheses around this 2 because it's not a negative base, but I just did out of habit. Okay, the power of a quotient rule says that if you have a fraction and you're raising it to a power, that you can raise the numerator to that power and the denominator to that power. Okay? So for instance, if you have like 2/3 raised to the 4th power, that's the same as 2 to the 4th power over 3 to the 4th power, or let's see, it'd be 16 over 81. Okay, so I wanted to introduce you to some of the expressions with exponents. Now, this is the rule that we just learned. I'm sorry, expressions with variables is what I meant to say. This is the rule that we just learned, and we have an expression here with an exponent. Now, we use the power of a product when we have variables in our expressions, because I can't take 3 and multiply it by x. This is how I represent the product of 3 and x. I can't actually multiply it because x is not the number that you see. Oh, by the way, sometimes you see instructions where it says let x be a real number, right? And this is not saying to you, it's not a direction to you that says, okay, let x, you tell me what x is. It's just saying that if x is a real number, how can I simplify this? Now, we know this rule works for real numbers, so that if it's a real number, I can take the each of the factors and bring the exponent in. That's all this is saying. It's saying, okay, imagine that x is a real number. What can you do with this what can you do with this product? Well, here I can take 3 and raise it to the 4th power, and then I can take x and raise it to the 4th power. I don't need to necessarily write with parentheses, but I get in that habit just in case there's a negative base here. Okay, 3 to the 4th power is going to be 81, and x to the 4th power is just x to the 4th power, like that. Okay, and that's it. Okay, power of a quotient, we saw that we can just take each, the numerator and the denominator, and raise it to that power. Okay, so that just becomes, let's see, it's 64 over 125. So that's it. Okay, oftentimes I just want you to do that step, but you can, I just went ahead and evaluated it. Let's talk about expressions with variables, because sometimes we get these expressions and we're asked to use the rules for these expressions. So this is just a monomial here multiplied by another monomial. So everything within this monomial is being multiplied together, right? Now, what this is saying is just 3 times x squared times y cubed times 4 times x to the 4th times y to the 8th. By the associative property, I can just write them without the parentheses, right? Because they're all being multiplied, so I don't need to keep the parentheses. I can drop them. By the commutative property, I can write the constants together, and I can write the powers with like bases together. Okay, and then I can just go ahead and simplify them. 3 times 4 is 12. This, I keep the base and I add the exponents. That's where the product of powers rule comes in, right? And then here I have y to the 11th power. And that's it. Okay, so it's it's 12x to the 6th power, y to the 11th power. Okay, the quotient of powers says that here I have a monomial on top and a monomial on bottom. And if this is the case, what I can do is I can think about these bases just being by themselves. If there's multiplication in between them, then I can think of x, just the x bases, and then the y bases. So this would just be x to the 4 minus 2 times y to the 3 minus 2, which is just x squared y to the 1st power, or x squared y. So that's my final answer, because I just subtracted the exponents. I kept the base and I subtracted the exponents. Power of a power rule says that I can keep the base and I can multiply the exponents together. So that's how I would get that answer. Okay, so here's a few more examples of the power of a product rule. Well, in this case right here, I take the monomial and the whole thing is raised to the power. So remember what that says, like this is the first thing that it says, every factor you just raise it to that exponent. So every factor here, 3, I'm going to raise it to 4. This is a squared, I'm going to raise it to 4. This is b to the 4th, I'm going to raise it to 4. Now I'm going to use my power of a power rule and say this is, okay, 3 to the 4th is 81. This is where I'm using my power of power rule, that's a to the 8th, and then b to the 16th. Okay. Here I'm going to make sure you put parentheses, because here you absolutely need them. It's negative 3 to the 3rd power, a to the 3rd power, a to the 3rd to the 3rd power, and b to the 3rd power. That's a little 3 right here. So here it gets to be negative 27, a to the, let's see, it's b to the 9th power because we're multiplying it, and b to the 3rd power. Okay, so what I did here was negative 3 to the 3rd power is just negative 3 times negative 3 times negative 3. That's negative 27. A to the 3rd power ends up being a to the 9th, and then b is just b to the 3rd. Okay. Here I take the 9 and I square it. And then I take the x and I square it, and I take the y and then I square it. So this just gets 81 x squared y squared. And that's it. Okay. This next one is the power of a quotient. So I just take the power and bring it into each of the, it's very easy because there's one factor in the quotient. It's not even, there's only one thing in the numerator and denominator here. So it's not that hard. The next one's a little bit more difficult because there's a product in the numerator and a product in the denominator. So what I'm going to do is first I'm going to take each of these products and raise it to this power. We have x to the 4th, y to the 3rd, raised to the 6th power, right? So here's my 6, and I'm putting it to both of them. And then after I do that, I want to use my the power of a product rule and bring them in. So this is just x to the 5th raised to the 6th power, and y to the 5th raised to the 6th power. And the bottom says x to the 4th to the 6th power, and y to the 3rd to the 6th power. Sorry, my 4s end up looking like 9, so just be careful there. And then the end, I use the power of power rule and say this is x to the 30th and y to the 30th, okay? And then x to the 24th and y to the 18th, okay? Now I can use my quotient of powers rule to say if I have the same base, I can subtract the bases, or subtract the exponent. So I have x to the 30 minus 24, 4, and then y to the 30 minus 18, which is x to the 16, y to the 12th. Okay. Oh, whoops, that's 24, so that's x to the 6. and y to the 12th. And that's it. That's all I have. Okay, that was the most complicated because that used the most amount of rules. It would use the power of a quotient rule right here. You use the power of a product rule, then you use the power of power rule, then you use the quotient of powers rule. So that was a pretty complicated one. But that's it. That's the end of the lesson for today. Thanks.